Hello and welcome to SIAM Speaks. Today we have a very esteemed guest with us, Mr. Andreas Volk, who is the CEO and co-founder of Bet Motors from Austria. Andreas, a very warm welcome to SIAM Speaks, and we are honored to have you here. It will be a pleasure to learn from your experience, from your vast, rich experience in Bet Motors, and to understand how those can be deployed to ensure that India fast tracks its adoption of electric vehicles. My first question to you, Andreas, is very particular to commercial vehicles. So, all these big trucks and buses, particularly the heavy commute segments, they need a lot of power and torque.
Yeah.
And to ensure that a very large battery has to be placed in a typical BEV, which ranges into hundreds of kilowatt hours per unit. Now, such heavy battery, of course, comes at the cost of payload penalty, I will say, because the amount of payload that can be carried certainly reduces. So, from your experience at Bet Motors, what strategies can be adopted by Indian OEMs and generally OEMs across the world to ensure that this payload penalty is minimized without compromising on the efficiency and the driving economics of the truck?
Yeah, of course, your question has a different content. I would split first particular needs for the Indian market. Yeah, Indian market is capex incentive, but nevertheless, the total cost of ownership is super important. And said this, you need to have a certain amount of install capacity of the battery. And if you take, we call this in BT Motors retrofit. That means you take existing truck, basically scoop out whatever was in terms of ICE engine, diesel, after treatment, etc., and with the leftover space, you generate an electric vehicle. This is retrofit. By doing this, you have the advantage, not advantage, the disadvantage of overloading the rear axle, which means a reduction in the payload.
Absolutely.
Not only that, if you make mounted battery packs, as is a retrofit to a leather frame, it means you need additional safety structures and support compartments to make a safe product. This reduces further the amount of space for active capacity as installed capacity and also increases the weight further. Therefore, we embrace Indian OEMs, not only Indian, all OEMs, to go the way it called purpose-built electric instrument. It means you take imagine multifunction components in a vehicle. Take the battery module as a structure element. Take axle compartment components as a structure element, and then you can neglect the normal components because the battery is heavy. You need to optimize the overall vehicle architecture to overcome the additional load. Because this is a truck, of course, main differentiator is payload. And the last part of your question was how and when, etc. It's called, I'm sure you know this, investor's dilemma. You have existing products as an OEM, and also you have market demands for new products. But how good will be the product market fit of your new R&D, research and development driven product? This is always, let's say, a balance. How much cost and energy of your organization you put in maintaining existing leadership or market placement versus how much you put in for the future technology, and embrace it to all start very fast.
Understood.
The Germans, sorry, last comment, don't follow the German approach. Okay, I'm a German. I can say this, okay? It's crucial. There are many companies in the world that move so fast. It's unbelievable. And India, with this strength of manufacturing and all the setup and also with the government support, it's almost idle conditions. But you need to start and you need to be fast.
Okay. Perfect. Thank you very much. My next question is slightly related to what we discussed in the first part about the big batteries of heavy trucks. So, big batteries for heavy trucks, that mean a lot of energy required to charge them, and a lot of time goes in charging these hundreds of kilowatt hours worth of batteries. And in a country like India, where the charging network is still developing, we have limited charging infrastructure on cross country highways. Once you move out of metro cities, you will find scant networks. And even there, it's not extremely super fast charging. The most we see is around, say, 50 kilowatt chargers. So, what learnings from global experiences can be deployed in India to ensure that once the adoption of electric trucks happen, charging infrastructure will not be a bottleneck?
First of all, you need to understand, or for transition to pure electric, everyone needs to understand how the grid and how the grid utilization and grid balance is done. Over India and all countries over the world, you have a certain grid utilization, you have a certain conversion rate of the grid, and you have the plants. Is it gas, oil, hydro driven, doesn't matter. You have certain amount of plants, and this needs to balance. Unfortunately, I have to say, all systems in the globe are built based on merit order principle. That means the supply with the highest cost most likely is also the driver for the overall cost and the demand. And this brings the issue, as the plants are built for ROI of more than 20, 30 years. And electrification is happening so fast. You have always a bottleneck between demand and supply.
Correct.
And this is an issue you can't overcome. Even if you push and you want to have it, you have to focus on certain locations. You can't deploy it everywhere. You will definitely lagging behind. Said this is to wait until public charging, rather private or a government-based. If you want to wait for this, I most likely guess it will take too long time due to the key factors I just explained, because the whole system is not set up for fast changes, because you want to have stable conditions. Therefore, you build a system for the stable conditions. What you can do instead, focus on regions where a lot of logistic is happening, make alliance with the different parties, private companies.
Correct.
The higher the demand is for a unit of electricity, the cheaper you get the price. So set this, imagine an alliance between bigger corporations. They have such low energy prices, plus they can share an investment. This is definitely, I would suggest, go-to approach to crack the infrastructure issue. That means you cannot be always and everywhere as fast as for the big alliance corporations, unfortunately. But instead of try to build everything up, go with the easiest one. And the easiest one is the bigger corporations, where they have a higher fleet demands. So you can forecast. This is much, let's say, the forecast versus the amount versus the investment is much more stable, as you would like to deploy all everywhere. And in India, anyway, correct me if I'm wrong, 60% of the transport logistics anyway happened in all those regions. That's almost that.
I'm not sure of the number, but it's a majority.
Yeah, something like this. Therefore, focus on that. And then after it, slowly, you can also build up in more, let's say, far away regions. And although if you have a battery electric truck, where the installed capacity is big enough to run more than 500 kilometers, you have another advantage, that you would consume 250 or 300 kilometers per day. And the rest you could use for charge, or you don't need as high infrastructure demand, because you simply do not need to charge as fast. Correct. And then you can stay with 60 kilowatt, 100 kilowatts, because within 5 to 6 hours, you charge enough to be ready for them at 300, 400 kilowatts.
Right. Fantastic. I think that was a very good insight shared, that alliance formation and scalability of controlled use cases can set forth the way, which can then be trickled down to ensure that electric truck mobility can reach everywhere. So thank you very much, Andreas. Thank you very much for the insights that you shared. And I hope that we as a country will learn from these and fast track our EV adoption. Thank you very much.
Thank you very much.